Well, welcome from my side to the Spring Framework session this afternoon here. It's my pleasure to be here for a start, and great that so many of you show up here. The purpose of this session is to give you a little bit of a tour through the Spring Framework component model. So it doesn't contain any bullet points. It's source code only, be warned. But I'm not going to do live demos. I'm rather going to show you source code examples on slides here and having a bit of a design discussion with you. The idea is that we are starting with the basics of the component model, and along the tour we're going to learn quite a bit about some nuances, some specific recent features in some corners of the programming model, and towards the end we're going to discuss the endpoint model. The messaging endpoints, HTTP endpoints. So we will be discussing a lot of stuff, actually touching upon a lot of stuff in this presentation. The Spring Framework 4.2 angle comes in several places. There are some new 4.2 features that I will highlight to you as we get to them, when they naturally fit into kind of the tour that we're doing here. This is not what's new in Spring 4.2. Spring 4.2 has way more new features than what I'm showing in here. I'm just going to show 4.2 features to you as far as they matter to the storyline. All right, well, maybe a couple of words on myself. My name is Juergen Hoeller. I'm actually based in Austria, so not that far off. And I'm serving as the Spring Framework project lead, the open source project lead for the Spring Framework project, as in github.com/project/spring-framework. And I've been doing this for a long, long time, for 12 and a half years in the meantime. So I've had the pleasure and the duty to guide Spring from its very early stages, from the 0.9 release up to the current 4.2. I'm also the release manager, so every single Spring Framework release in the entire history was signed off by myself, and I keep doing this. I'm also doing the roadmap planning, so towards the very end of the presentation, I'm also going to just spend a minute or two on the roadmap for next year, on 4.3 in particular, and a little bit on 5.0. But that's kind of the bonus, right? The purpose of this presentation is to show the state of the art. Today, there's Spring Framework 4.2.1 now, 4.2.2 appearing next week. So I'm talking about things that are already here, that you can use immediately, basically today, if you want to, right? This stuff is also already fully production supported, as usual with Spring Framework releases. All right, so far for a little bit of a preface. Let's start with the heart of the component model. This is a component class. It's basically just a regular Java class with some little fancy annotations mixed into it. In the Spring component model, we are very Java language centric in the sense of taking the Java language as it is, idiomatically. The same applies to Groovy as a side note, but we take each language the way it is. We're trying to expose the natural capabilities of the language to the best possible degree, and we're trying not to bend the semantics of the language either. So it is a regular Java class with a couple of formal metadata elements attached to it that tell us something about the class. For a start, those annotations have a readability aspect to them, right? You're looking at a piece of source code, and those annotations tell you something about that piece of source code. This is a MyBookAdmin service class. It implements some service interface, but it doesn't just say it's a service in the name, which is arbitrary, right? Any name for the class could be used here. It also formally declares itself as a service through the @service annotation on top. This is a pretty important part of it, right? Informally, you may understand that certain classes have a service role in your architecture. But by turning this into a formal annotation, it's not just supporting your own understanding of the code when you read it, it also allows tools and the runtime framework to reason about them. If it's formally an add service, then some other parts of your setup can react to this service nature of the class. Certain aspects, AOP aspects, for example, may kick in based on the service annotation. There's a different kind of annotation showing up at the constructor level, at AutoWired. This is very core, of course, to Spring. It's a dependency injection annotation. At AutoWired indicates that this constructor is supposed to be automatically wired to other components in the system when being managed by the runtime framework. So, of course, it's primarily a constructor, right? You could just call it with new, pass in an account repository, and all will be good, for example, for a unit test. In a typical Spring Framework scenario, it's the framework's responsibility to create the instances and manage the lifecycle of the instances of this class for you. And the framework will use this constructor because you annotated it with @AutoWired. If there are any other constructors, the framework is going to ignore them. So it's just going to look at the annotated constructors. There can be more than one. The most powerful one that's satisfiable will be used. There's an algorithm behind this. But in an ideal world, there's just one that's annotated. That's the one that the framework is going to use. Pay attention to the readability of it. This constructor is AutoWired. This class is a service. You can actually read those annotations next to the Java elements in a very natural way. This also applies to the third kind of annotation down here, @transactional. A typical example for an annotation that allows you to tap into a middleware service. Semantically, what you typically want to achieve here, right, is a runtime annotation wrapped around the invocation of this method. A transaction to be started before we enter the body of the method, and when the method returns, we're going to complete the transaction for you through a commit or rollback, etc., etc. There's nesting of annotations, propagation levels. That's really not that important for our current purposes here. Let's go back to the readability side. This method is transactional. It actually reads quite nicely. The point of @transactional's name is to allow for reading it. This could be called differently, right? It could be called @transaction attribute for a completely made-up example. No, it's not. Right? In EJB3, it's called @transaction attribute. But the readability really works if the naming of the annotations takes it into account. An AutoWired constructor, a transactional method. Right, so that's basically the heart of the component model. In further steps, we're going to learn about a few of the nuances. I'm going to take you in different directions now. This is a pretty personal, somewhat subjective selection of favorite features. It's not a full discussion of the capabilities of the component model. It's just a couple of feature highlights that may help in understanding the design and just show you how far you can take some of those things. A particularly important one in recent years is composable annotations. Annotations in Spring, in almost all places, can be composed. This means that you're designing your own annotation, like shown above. An annotation is just a Java type, right? Public @interface, give it a name, and you just created an annotation. Just like any other Java type that you're declaring in your codebase. This custom annotation, keep in mind it needs to be retention runtime, otherwise no framework in the world is going to be able to read it. So that taken into account. The interesting part is actually the 4 annotations on top. It's a custom annotation in your codebase, here called myService. It's meta-annotated with @service, so it's kind of inherits the characteristics of a standard @service stereotype in Spring. It changes the default scope to session. The default scope of a component in Spring is singleton by default, so a shared instance. So it changes the default scope to session. It indicates a primary role. This has an effect in injection scenarios when there's more than one match for a type. So if you're injecting like a book admin service, but there are two of them in your system, we are going to take, if in doubt, we're going to take the one that's marked as primary. It's a kind of simple qualifier, you could say, in other terms. But anyway, those characteristics, even injection characteristics, can be put into this stereotype as well. And there's even a default transactional rule. So there's add transactional in there with a rollback rule. All of those characteristics combined on one myService stereotype annotation. And whenever you're using it, like on any class in your codebase, wherever you're saying add myService, what you're really saying is, I'm in an add service, I'm in a default scope session, primary role, and a default transactional role. So it's a kind of shortcutting model. You have a sweet little shortcut called add myService that means all of those things in combination. There are a couple of subtle little benefits in this one, right? It can be seen as a shortcutting model, but it's also a custom stereotype in this case. myService is up to you to find a proper name for it, right? Please do not call it myService. Find a better name that has a meaning in your architecture, right? Call it order service, account service. Use some vertical or some horizontal slice in your system where these kinds of stereotypes have a meaning. Identify a specific role in your application architecture. At that point, it also becomes a matter of guidance. You can use a nice, properly named annotation that combines a number of characteristics into one element. Across a team, the development team can consistently use those custom annotations and apply consistent semantics to many components in your system. This can be taken even further, because it does not just work on stereotypes. It works for almost any annotation in Spring. Almost any annotation that you're currently using could be replaced through a custom annotation. So, two examples here. A scoping annotation and a transaction annotation. And there are a couple of nice little twists here as well. The scoping annotation is named mySessionScoped. It has a meta annotation addScope session, so it's kind of an alternative to addScope session. It has this little benefit that it's hard coding the session name, right? So at mySessionScoped does not have a string scope name anymore. It carries the session nature in its own name. So you can't have a typo, right? In that sense, it's a type-safe session annotation. This custom annotation still allows for overriding the proxy mode, another little subtle element here. Because in Spring, scoped beans can have a proxy mode. They cannot be proxied at all. You get the raw instance. They can be proxied based on interfaces, or they can be proxied based on the target class. And the proxy mode allows you to control this per component. This custom mySessionScope design here exposes this flexibility through redeclaring the proxy mode attribute. So proxy mode is actually an attribute on Spring's standard addScope annotation. By redeclaring it on your custom annotation, you allow the users of your custom annotation to still tweak the proxy mode, right? If you're not redeclaring it, you're kind of hard coding it. Any user of mySessionScoped will be unable to change it, which you may, of course, want to, right? It's your choice. Do you want to predefine the proxy mode? Do you want the user of your annotation to choose the proxy mode? Again, a matter of guidance across a wider development team. In the transaction annotation below, this may become even more obvious. myTransactional, no arbitrary name, of course, here. addTransactional as a meta annotation has a fixed rollback rule. Most of the attributes on addTransactional are not redeclared. addTransactional has like a number of attributes. It has propagation behavior, isolation level, timeout, rollback rules, and so forth. None of those are redeclared, which means the user of your custom transaction annotation cannot actually change those because you don't want them to change it. You do choose to redeclare the read-only attribute here, and just the read-only attribute, so that any user of my transactional can still give a hint about whether this transaction scope that you're operating in here is conceptually read-only or also allows for read-write operations. Read-only in Spring, as a side note, is a hint. So you're not enforcing read-onliness, it's not an assertion, it's an optimization hint. By saying read-only true, you allow the runtime behavior of that transaction to optimize itself for read-only purposes, which, for example, with the MySQL driver means that you can go to, in a cluster scenario, you can go to the slave nodes, not just to the master node. In the case of Hibernate, it means we switch it to flush mode manual. We're never flushing because the objects are not supposed to be modified anyway, so why look for changes in there? So it's an optimization hint that we're automatically applying, but you need to give us the hint, right? We don't know whether it's going to be read-only. And this custom transaction here does not declare a default. In contrast to the one above, there's no default for the read-only attribute, which means every user of your custom annotation, my transactional, needs to explicitly say read-only equals true or read-only equals false. You're forcing them to set the flag. So you're forcing them to think about it, right? You're forcing them to reason about it. It's pretty easy to forget about it, right? If there's read-only false as a default, a lot of people are not even going to think about the read-only flag. This way, you're putting it right in their face. So much for some subtleties, but custom annotations really allow you to do a lot of things. Shortcutting, but in particular guiding a development team towards the consistent use of some features or the consistent non-use of some features. Right, if you're interested in the composability space here, a final note on this one, a recent Photo 2 feature. If you prefer explicitness, you can also be very explicit about those references. This is the same examples as before, for the same purpose, but now it's using the Spring Photo 2 alias for annotation, which for overridden attributes explicitly, formally points to the attribute that it's overriding. So it's not by name anymore, it's by declared reference, which adds a little bit of flexibility and makes the arrangement a little bit clearer. Right? You see that the mode attribute there is an alias for the proxy mode attribute in the scope annotation. So even for an innocent reader of this piece of source code, it's a little more obvious what it actually means. That's the main reason why we added it. But it also adds a little flexibility. Notice that the mode attribute above refers to the proxy mode attribute in the scope annotation. So with the use of alias for, you can rename the attribute to any name that you want. In this case below here, it's not renamed, right? Obviously, you don't have to rename it. All right, so much for the composability. Let's switch gears a little and go back to configuration classes. A very central element, in particular in the modern day configuration story. If you want to see this in full action, have a look at Spring Boot, right? I mean, Boot is heavily configuration class based. But for the purposes of this presentation, I'm just going to highlight a few of the design elements here. A configuration class in Spring is essentially just a regular component. It's registered like a regular component. It has a stereotype at configuration on top. It can be detected through class path scanning, like any other component in Spring based on that stereotype. It's registered, has a life cycle, has instance state. The purpose of a configuration class is to have @bean methods. @bean methods declare further beans for the context, right? In a Spring Boot scenario, all of the beans in your Spring context are going to be declared through @bean methods in an arrangement of configuration classes. there can be any number of configuration classes with any number of adbean methods. It's your choice in terms of the granularity. So an adbean method is essentially a factory method. You're declaring a bean, you're exposing it to the container. This is a named bean because the method name is the bean name, right? So it's called myBookAdminService. The return type of the method is an indication for type matching purposes. So the container is able to look at the return type of this factory method to have an early understanding of what type is being produced here. And whenever it needs to actually create an instance of this bean, it's going to invoke your factory method implementation. This is a session scoped bean. So for any session, HTTP session typically, where you're actually referring to this bean, we're going to create one shared instance for this session. The container is going to invoke the factory method every time. It's a factory method, not really a lookup method, right? So it's only going to be invoked for the creation of a fresh instance that the container will then manage the lifecycle for. The factory method may be super trivial. It may just say like return new myBookAdminService, that's it. Or it may be a little bit more involved. You may call builder APIs in here, maybe some simple static factory methods of some kind, or you may pre-configure the instance by referring to other beans, which is what this particular method is doing. It's referring to a bookadmin data source not shown here, some other adbean method that you are programmatically declaring a reference to. So instead of using injection within the class, you may also design a factory method that can be wired to other components through explicit programmatic references. So that's a kind of a bonus feature in configuration classes. Well, on top of this, to wrap up this little discussion of configuration classes can have two further kinds of elements. Back to the top, there is not just add configuration as a stereotype, there's an add profile. Add profile is one example for a condition. Configuration classes can be conditional. They can contain metadata that says like, only activate this configuration class if a specific condition is actually met. And add profile is a very simple kind of string condition. There's a profile setup on startup, typically a system property. And if that system property is marked as a standalone, if one of the active profiles is named standalone, then and only then this configuration class is going to be registered. Otherwise, it's going to be skipped. There is a pretty elaborate conditional model behind this. So conditional is actually a dynamic mechanism. You can have a condition implementation associated with a class where you can dynamically react to the runtime context. You can try to find out whether other beans are present or not present, whether certain settings are set or not set, whether you're running on a certain JVM or not. So condition classes are a dynamic model where you can programmatically implement an algorithm to decide whether certain components are to be registered or to be skipped. And that's what Spring Boot does. That's the enabling mechanism for Spring Boot. Spring Boot heavily uses condition implementation based on the presence of some beans, the non-presence of some beans, the presence of certain classes in the class path, where it automatically registers certain resources if the driver is on the class path. That's what Spring Boot does. But the heart of this is this configuration class model with basically the feature set as explained here. Enable annotations, to quickly mention those as well, are also pretty common in the Spring Boot world. They are kind of a shortcut to opt into certain framework functionality through a nice little declarative element. Enable transaction management switches on the processing of transactional methods and expects a transaction manager to be declared. Spring Boot has many of those, right? Enable auto discovery, enable almost anything. Enable is basically the kind of successor of the XML namespace arrangement, where we had namespace elements like context annotation config and those kinds of elements, TX annotation driven. At enable is basically a kind of Java-based mechanism doing the same thing. So, 2 notes here. In Spring, in traditional Spring Framework setups, your configuration is pretty explicit. You're not getting any magic unless you're asking for it. So there is no transaction interception going on unless you declare at enable transaction management. You need to opt into it. It's a simple 1-line opting in per application, just once per application, but it needs to be done. So Spring is very explicit. It's a what you define is what you get kind of configuration arrangement. Spring Boot is a little different, right? Spring Boot automatically does quite a lot of things for you. But keep that in mind. Fundamentally, even in the boot world, many things only work if you actively opt into them. You may choose to ignore them. You may opt into cache annotation processing. You may opt into even transaction management, which means by default, no surprises, right? If you did not ask for it. And Spring does not create default resources either. So no default thread pools, no default transaction managers, unless you're asking for it, unless you're declaring them. All right. So much for that, really. And maybe one note also that fits in here. All of this works just because you're doing it in your source code. So everything you've seen here, including the composability of annotations, for example, works out of the box. Just use your annotations, right? Just do things like stick at my service on a class. There's no need to register this anywhere, no need to set up anything special. Just do it and the framework automatically detects it. There's no extra setup necessary here. The framework automatically understands the meta annotation arrangement, the configuration class arrangement, and everything else. All right, let's take configuration classes a little bit further for some more for the two-oriented features here in a rather quick note. You may just expect this to work, but yes, it does work. Configuration classes can be part of a class hierarchy. So if you choose to have a configuration Java class that extends a base class, we're just going to do the obvious for you. We're going to look for @bin methods across the hierarchy. @bin methods can get overridden. The base class can have one version of the method, the subclass overrides it. The base class can have an abstract factory method that the subclass then substitutes. So you can have base classes that kind of predefine an arrangement. You leave it up to subclasses to kind of complete the pieces. Configuration base classes can be used, for example, to ship some library modules or framework modules for the use across the corporation. And in every single project, they create specific subclasses of the base class that you provided. It's traditional Java inheritance composability, though. So there's nothing special, really. We're just doing the obvious when you're using this standard Java mechanism in a configuration class. In Spring Framework 4.2, we're even going a little bit further. What if you started to use default methods, Java 8 default methods? It's just a configuration class, but the configuration class up there does not extend the base class. It implements an interface, and this interface, my bookadmin config here, happens to declare a Java 8 default method. So it's kind of a, in Java 8, interfaces can have methods with a body. They cannot refer to state, but they can provide an implementation. So standard Java feature, we cannot prevent anyone from using it. So if somebody's using it, what if it is annotated with @bin? We used to not do anything special about it, so we don't find this through standard reflection, so it did not work. But as of Spring 4.2, if you happen to do this, we're going to find those methods as well, and we're going to register them just like any other @bin method in this particular class hierarchy. So you're getting the obvious. All of the @bin methods are going to be registered for you. You can choose to put them into base classes. You can choose to put them, if it helps your purposes, to put them into default methods. The sweet spot for default methods in interfaces is that you can implement several interfaces. It's a kind of multiple inheritance. My application config can say implements my bookadmin config and my repository config, 2 interfaces. And you're inheriting the admin methods from both interfaces. So if you have this kind of flexible configuration setup where several pieces are to be combined that way, you could consider using default methods in interfaces for it with standard Java language semantics. So we're not doing anything about the language semantics. If you're redeclaring that method in your concrete class, of course this concrete method is going to be used. If you're not doing this, you're going to inherit the default implementation. All right, so that's also a little bit of an advanced example of how we take the Java language rules, in particular in Java 8, and kind of try to naturally support them, so that kind of the obvious understanding when you read the source code actually works at runtime. Configuration classes can be ordered. It's another somewhat advanced feature, but keep in mind that in particular in a class path scanning scenario, there's no guarantees for the order. You may end up with almost an arbitrary order of registration, and in a heavily singleton-based application with many components that get bootstrapped on startup, it may matter which of the ones gets initialized first. There may be subtle dependencies between the components. Spring has a number of facilities to kind of express those dependencies, including a depends-on annotation between components. You may also use ordering. Ordering works in many places in Spring. So if you're thinking that in this particular case, the framework should pre-order the components for you, try to stick an order annotation on the components. The framework usually reacts to them in almost any places where it makes sense, including configuration classes. If we find them in the class path on startup, whatever the order of traversal, we are going to register them in the right order for you, with this one kicking in first, then the one above. You may use this for any purposes, but it's in particular important for overriding beans by name, where you obviously want to override to be processed last to actually override the other variant. Right. We're going to revisit ordering in just a moment, but let's switch our perspective a bit again and look onto the injection point side of things. So not on the declaration point where we are declaring beans in configuration classes. We are looking at regular components in your architecture, in your system, in your code base that are receiving components from the runtime context and how those mechanisms interact. So let's assume we have a component, my bookadmin service down here, with a constructor marked as @autowired, and it happens to declare a my repository of account. So what if this constructor declares a generic type? A generic type with a concrete type variable substituted here. My repository is not shown here, but just imagine this is a custom type of yours, some interface of yours with a type variable. Maybe a repository interface with find and save methods with a type variable t, and this one is substituted with account here. As of Spring Framework 4, we're taking this into account even for complex nested arrangements, but more importantly for these simple arrangements, where we are going to find a match for you that actually matches my repository of account and not just my repository. We used to just look at the primary type. Everything else required a qualifier. As of Spring Framework 4, there's a full type matching algorithm for any kind of type variable information here. So consider the two bean declarations above. If there's an @bean for a my repository of account and another one for a my repository of product, and then you look at this injection point again, it's obvious which one we're taking, right? Just by looking at the source code, you expect us to pick the my account repository, not the other one. As of Spring Framework 4, that's what's actually happening. In Spring Framework 3, you would have had to add extra metadata, like a qualifier account, qualifier product, some kind of extra metadata. We're not doing this anymore because we are on a mission to avoid extra metadata if the source code itself is expressive enough. So if the type declarations in the source code itself are expressive enough to support it at runtime, there is no need for extra metadata, no need for qualifiers. In a typical modern-day Spring-based application, you will hardly ever need qualifiers. Right, a variant of this. You may choose to declare a list of my repository of account. Well, we do the obvious for you. We are going to look for my repositories of account in the set of beans in the system, in the context. We're going to take them and assemble the instances into a list that we're then injecting. So we're going to take both of the beans above because they are both in my repository of account. But you asked for a list, right? A list implies ordering. Well, that's where add order comes in again. So we're going to take both of those beans, the one with the my repository, my account repository Y1 first, then the X1, because we're going to pre-order them for you according to the add order values. And that's the list that you will get. So this kind of arrangement can be taken to almost any level, right? You get the idea. You can have nested type information here, you can have any combination really. In case you're wondering how we resolve the generic type information in a world where there's type erasure, right? In common understanding, the JVM does not preserve generic type information at runtime. That's not actually true. Type erasure just applies to instances. A concrete object instance of my repository does not know which type it has been declared for. So if you have a my repository instance, an object in your hands, it's a little hard to find out whether it's for account or for product or for anything else. However, this type information is being preserved in signatures, in constructor parameters, return types, field types, of course also method parameters, method return types. In all those places, the JVM does preserve the type information, and that's exactly what we're using here. Notice that, of course, this is a parameter, a constructor parameter, my repository of account, and up there, it's a method return type. Both of those can be introspected at runtime, and both of those can be matched. The actual matching algorithm is the same that the Java compiler uses. So just imagine you have a variable of my repository of account, you're trying to assign an object to it. If the assignment works in the Java language, in the Java compiler, it's also going to work at runtime here. The algorithm strictly follows Java language rules, including the fallback. You may remember that there's an unchecked assignment. You can say like, here's my repository of account, here's an untyped my repository, please assign it, assuming that it's compatible, right? An unchecked assignment, suppress warnings unchecked on top. Even that is possible here as a fallback algorithm, because the Java language allows it, we allow it too. So if there's no my repository of account in the context, just a regular generic my repository, we're going to fall back to that one, but only as a fallback. All right, so much for a little bit of the discussion here. Some variations of signatures. Again, a my repository of account, just like before, but this time the parameter is annotated with @lazy. Now, what's this @lazy business? @lazy can be used at the declaration point, like above, and it can also be used at the injection point below, at both ends, and it has somewhat related semantics. @lazy at the declaration point, on a factory method, on an @bean method, means that the container is not going to initialize this one on startup just because it's there. It's only going to be initialized if some other component actually refers to it. Then and only then it's going to be initialized. It's basically a lazy initialization hint. At the instance level, at the lifecycle level. If you're using it here for a constructor parameter or a method parameter or a field, it has a slightly different meaning. You're saying this, my repository of account here, this repository reference can be lazy. So you're allowing the container to give you a lazy proxy to the actual target object, because you're formally saying here, I don't need a pre-initialized object right now. All I need is a reference, which I can maybe store in a field and use later on. That's what @lazy says here. If you're not declaring @lazy here, the framework assumes that you want a fully initialized repository instance, because you could be using it right there in the constructor, right? You could start calling it right there in the constructor. That's unusual though. In most cases, you're going to use it later on. Just store it in a field. And that's exactly what @lazy supports very nicely. And it also reads pretty nicely. This is a lazy repository parameter, a lazy repository reference. Can be expressed per parameter, right? A constructor in Spring can have any number of parameters. In many cases, it's usually one, but there can be any number. And each of them at the parameter level can be marked as lazy if necessary. This can also be used to resolve cycles. Like if you have a circular reference, component A uses B and B also uses A, @lazy can be a nice way to break the cycle. Because a cycle is only a cycle if both of them insist to have a fully initialized version of the other. Only then it's a problem, right? Because obviously you can't satisfy that requirement. By marking at least one as @lazy, the cycle is not an issue anymore. All right. Slightly different perspective again. The use of standard annotations. In this presentation, you're primarily seeing the Spring variants, because the Spring versions of those annotations are usually way more powerful. And in particular, they are composable. If you don't need the extra attributes, and if you don't need the composability, then there are a couple of standard annotations that you can choose to use, and they just work out of the box. So no need to activate anything, just use them over here, right? So that's @manage_bean for the stereotype, @inject for injection purposes, @prestrip for a shutdown method. We support annotations from JSR 250 and from JSR 330. So that's where those are coming from. @inject is from 330. The other two are from 250. Well, a couple of variants to conclude the base tour and give you the bonus section. The use of a couple of Java 8 types is now also supported, including the use of optional for parameters. So what if you came along and in your own source code declared optional of my repository of account in that signature? Well, that's Java util optional, right? Java 8's optional type. So we auto-detect that that's what you're declaring, and we automatically give you an optional handle for it. So nothing to do on your side, just declaring optional, and you get either an optional wrapping the actual reference, or you get an optional empty instance. And you can take it from there. Optional has some nice methods to chain the calls and react to the presence of the component. So instead of using the required flag, where you can ask for a null reference if it's not actually there, you can also choose to use Java util optional here, since Spring 4.1. Talking about Java 8 features, pointing out a couple of obvious things that you may just expect to work, and they actually work. If you happen to use any kind of Spring features against Java 8 datetime types, the support automatically kicks in. So if you're, for example, using Spring's formatting framework to render out certain values in a text representation or to bind incoming string values to the typed fields, if you choose to do this against the Java 8 java.time types, like local date, local datetime, and so forth, it just works. Spring Framework 4.2 still supports JDK 6 and 7, but as you probably figure here, if it's running on Java 8, it automatically activates a lot of Java 8 support. this included. And a nice little twist up there is that the type, again, is very expressive. So if you look at, for example, the birth date field, it's declared as a java.time.localDate. Local date is pretty expressive. We know that we are talking about a date, not a date plus local time within the day. So we can infer a default representation from the type. There's no need to specify at datetime format for ISO date, because the type itself has a default representation of ISO date. If you're happy with the default representation, there's no need to add extra annotations, extra metadata. So again, continuing that story, avoiding annotations if the type itself is expressive enough. The same arrangement works with JODA-time, by the way. So if you're using the JODA-time versions, we're automatically detecting them, automatically inferring default representations from those as well. It does not really work with Java util-date. Guess why? I mean, Java util-date just is not a very clearly defined type, right? Can be almost anything. A timestamp, a date reference, a datetime, no one knows, right? With Java util-date, we need this extra information because the type is not expressive enough. So by all means, use java.time and the JODA-time types if you can. We even do this as of Spring Framework 4.2 to the money and currency types. Brand new JSR 354, the javax.money package, released about half a year ago. If you happen to use the arrangement there, in particular the monetary amount type and the currency unit type coming from the javax.money package, we're auto-detecting your use of those types, and we automatically understand how those need to be rendered and how those need to be parsed. You may also choose to assign formatting patterns to those, very similar to what we just saw for the java.time package. So we even do this for the javax.money package as of Spring 4.2 now. Another Java 8 twist. The features shown here, async methods and scheduled methods, have been around since Spring 3.0. So they've been doing their job for quite a while, but there are two Java 8 twists here. Look at the completable future signature here in the middle. That's a Java 8, Java util concurrent type, a new one in Java 8. If you declare your async methods to return a completable future, Spring understands what you did here and automatically wraps it in a completable future that you then get when you invoke the async method. Because Spring is going to intercept them and give you a handle that's being passed on to a thread pool. Spring understands the completable future type now. Another little Java 8 twist down here in add scheduled is, the arrangement here, right? Two add scheduled annotations on the same element. That's actually only possible as of Java 8 now. Java 8 allows you to repeat annotations that have been declared as repeatable. Some Spring annotations are declared as repeatable now, so you can use them just next to each other, assigning two cron triggers to the same method. Otherwise, you would have to have this kind of wrapper annotation. All right, so to wrap up the tour, this is already quite a bit of ground that we covered here in the core component model. With this kind of design mindset in your mind, let's review quickly what the endpoints look like. A Spring endpoint is just a regular component. It has a controller like address controller on top, and we use mapping annotations for handler methods. I assume you've seen Spring MVC handler method endpoints. That's what they look like, right? Request mapping annotations and a couple of hints maybe in the parameters at path variable for how to resolve the parameters to those handler methods. Now, this is not just a Spring MVC characteristic. If you're processing the STOMP message protocol on WebSockets, which you can do with Spring Framework proper as of Spring Framework 4, this is what the endpoint model looks like. Does it look familiar? It's mapping annotations, message mapping and subscribe mapping, referring to the STOMP protocol, with the same kind of semantic, the same kind of invocation arrangement as with HTTP endpoints. If a matching message comes in over the STOMP WebSocket channel, this is what we're going to invoke. Now, You can even do that for JMS endpoints. So look at the version above. A JMS listener annotation attached to a method turns this method into a message processing endpoint, very similar to an HTTP endpoint or a STOMP endpoint. It's referring to JMS semantics here, though. So if you want to configure some JMS stuff, look at the version below, right? You can fine-tune almost any JMS binding instruction from the selector to the concurrency level. But in the end, it's the same kind of arrangement. Annotation-based processing endpoints, whether for the web or whether for a messaging scenario, for a messaging architecture. You can even do this to listeners now, to event listeners, as of Photo 2. If you're processing a lot of Spring application events in your architecture, why not use @event listener? It allows you to turn a method into an event listener callback. Every time such an event is going to be published in your application context, this method is going to be invoked. Instead of having to implement an application listener interface in a class, you can turn a simple method into an event endpoint. The idea here is, it's very similar to HTTP endpoints and messaging endpoints. You just happen to be processing application events here with application payloads instead of HTTP payloads or message payloads. So there's a very intentional analogy here between all of those endpoint models. So they are supposed to be as consistent as they can, of course, while still retaining their domain, right? Whether you're binding to the HTTP endpoint model or to the JMS endpoint model or to application events does make a difference. So there are specific annotations with specific attributes, specific conditions, and so forth. But design-wise, stylistically, and from a readability perspective, they are very consistent. All right, last but not least, you can also do this to caches, and we're not, for timing reasons, not going to cover this in much detail, but it shouldn't come as any kind of surprise, right? How do you do declarative caching in Spring? You're using a very specific set of annotations on your methods. You activate @enable caching and assign a cache manager implementation. That's all you need to do. The actual interaction with your components can be done through annotations such as @cacheable, just taking the signature, turning it into a cacheable method, computing the key from the incoming parameters, taking the return value as the cache value. It shouldn't come as a surprise at all following the design discussion that we just had. And a variant here, which shouldn't come as a surprise either, is of course you can use the standard JSR 107 annotations from the javax.cache package. If you choose to use those annotations, Spring auto-detects them, uses them the same way. They are not composable. The other ones are. The Spring cacheable annotation is composable. They're not composable. Maybe they don't read as nicely, but they're fully supported as you would expect them to, just through using them, choosing to use them in your own source code. Well, so much for this little design discussion here. Thanks for paying attention for so long. Of course, I'm happy to take any questions, whether in the official channel or by just coming up to the stage afterwards. I'm here all afternoon, all day anyway. Just a little hint, we're currently working towards Photo 2 coming next week here. And we're working towards a Spring Framework Photo 3 release, a new feature release, again with fine-tuning of the story in several corners, towards April next year. So we are not at the end of the story yet. There's going to be some more fine-tuning coming your way in just about half a year. All right, thanks for your attention so far. Any questions? Otherwise, if there's anything, come up to the stage, please. Thank you.